Let us locate the position and find the nature of the image. First of all, when the object is beyond C. Beyond C, I am drawing an object of height 2 centimeters. At the same with the same length, I am keeping a point here to draw a parallel line. Otherwise, the line may not be exactly parallel. I am keeping a point here. So this is the object. First of all, from the top of the object, we have to draw a ray parallel to principal axis. This is ray 1. Among the specific rays, this is the first ray given in the textbook, or else one of the rays it is. So first of all, draw a ray parallel to principal axis. After reflection, it goes through focus. So draw the direction of the incident ray. Now from the point of incidence and through focus, draw a line which will be the reflected ray. So be careful while drawing. You should not make any mistake. Right? So this is ray passing through focus, reflected ray. For easiness, take another ray through center of curvature. It is possible to take ray through center of curvature, though it is not falling on the mirror, no problem. So you take a ray and draw in the reverse direction. Ray passing through C after reflection goes back in the reverse direction. So if this is incident ray, reflected ray will be in the opposite direction. If you don't want to draw this, as it is not meeting on the mirror, so you take the ray through focus. Even if you take the ray through focus, the reflected ray should meet here itself. If it meets, your drawing is correct. You did not commit mistake anywhere. So let me draw now. Let us check once. That is what, if you draw exactly without any mistake, it will pass. It will meet at the same point. So this is the incident ray passing through focus after reflection. Let us check the distance of this. It is at a distance of 12 centimeters, exactly 12 centimeters. With 12 centimeters, I keep a point here. Sorry, I should not rotate it. So I am joining a line through point of incidence and the point kept just now. It is not going. Even though it is not going, we will adjust it so that it should go through the. So the slightest mistake, the little bit of mistakes we make. This is at a distance of 12 centimeters. Even 1 centimeter distance also, it won't let pass through the. So the reflected ray is passing through the same point. So whatever you have drawn is correct. Right? So you can draw any two rays. I have drawn three rays here, R1, R2, R3. You have take only two rays, not three rays. Why I have drawn, why I have taken three rays here is, so whether you take three rays or two rays, the image will be at the same point. Now, the incident ray started from top of the object. This will be the top of the object. This will be the image of the top of the object, and as the base is on the principal axis, base will be here in the reverse direction. So draw a line here. This will be the image. Position nature of the image when the object is at C. When object is at center of curvature. I am keeping a 2 centimeter or 1.5 centimeter object. I am drawing a line. Let us consider this as object. I am keeping 1.5 centimeter line at C, so that it works as object for us now. With 1.5 centimeters, I am keeping a point here in order to draw a parallel line. Otherwise, I cannot draw exact parallel line. Right? So now I am taking a ray parallel to principal axis from the top of the object. Always we should take two rays from the top of the object. Somewhat little bit of down it is, no problem. So this is incident ray. As we know, the ray parallel to principal axis after reflection from a concave mirror passes through focus. So we have to draw a ray through focus now from the point of incidence. Alright. So this is the ray parallel to principal axis after reflection passed through focus. Now we cannot take the ray through C. There are two options for us. One ray, another ray we can take through focus, or another ray we can draw incident ray at P, and we have to measure the angle. So it will take time. So let us draw a ray through focus now. Actually, it is not passing through focus. Focus is here. I have done mistake somewhat actually. I may not get here. So this is not focus. This is focus actually. There is slightest mistake is there. Even the slightest mistake will not give proper diagram. This will be the reflected ray, not this, right? Now let us take a ray through focus. Ray after passing through focus from a concave mirror 1.5 centimeters. This should also be exactly one as it is passing through focus. This distance, as the object distance is 1.5 centimeters, here also this distance must be 1.5 centimeters. Then only it will be parallel to principal axis. Here on careful observation, we know that 8 1.5. So it is also exact distance of 1.5. So our this line is exact actually. Now at 1.5, I will keep a line here. 7, 8, 88. It is 6.5. I'll keep a point here. Now this is the position of the, not this. So now we got exact position. Otherwise you would have gone wrong here. So even slightest difference giving image at wrong position. Now this is the correct position. So when the object is at C, image also will be at C. Inverted image, real image. So here the image is formed because of the actual intersection of the reflected rays. Here reflected rays intersected. So when intersected rays converge like this, a real image is formed. So remember RID, read. R stands for real or virtual. Read. Remember the word read. Real or virtual. So real. So it is real image. Inverted or erect. So it is inverted image. Reverse there, no inverted image. Diminished or enlarged. Same size. So if you say diminished, you have to think of the three things: diminished, same size, enlarged. So same size, place at C itself, right? So these are the characteristics of the image formed when the object is at C. Now when the object is between P and F, position and nature of the image. When the object is between P and F, I am taking an object of around 1.5 centimeters because the image will be large. Small object I am taking. This is the object, top of the object, and at the same height. Let me measure the height once. exactly 1.5 centimeters. I am keeping another point with 1.5 centimeters to draw parallel ray. Now this is the ray parallel to both are also somewhat from bottom. I have taken a ray parallel to principal axis. After reflection, it should pass through focus. Right? So here, even if there is slightest mistake, there won't be any problem here. When you draw image at when the object is at C and F, even a slightest mistake also you won't give you the proper result actually. Here there won't be any problem. So the reflected ray is passing through focus. Right. Now take another ray through C. What you do? At the top of the object, I'll draw a line passing through top of the object and C. First of all. It should even meet the mirror. Right. So draw this. Why we have drawn this is the incident ray along the normal won't deviate. So that is why the ray going in this direction along the normal, after falling on the mirror, it reflects in the opposite direction. So we have to take this ray also. On observation, we can know that here the reflected rays are near here. Here they are far away, somewhat compared to this. So the reflected rays are diverging. When the reflected rays diverge, we have to extend them in the back side with dotted lines because there won't be any rays at the back of the mirror. So we are managing the reflected rays in the back direction. Yet we have to draw them with the dotted lines at the back. So still they did not meet. Again extend again. That is why I have taken object of 1.5 centimeters. If we had taken 2 centimeters, it will be again difficult. They would not have met on the paper. I need to extend the paper actually. Right. So this is their meeting point. So there will be virtual image. So erect image as this is the top of the object as the incident rays start from top of the object and as they met here this will be the image of the top virtual image and this will be the base. So that's why so this is erect image. I told you remember RID read. R stands for real. So it is real or virtual. So virtual image will be formed. Inverted or erect. Erect image will be formed. Diminished or enlarged. Enlarged image will be formed. Last position. where is position behind the mirror, right? So these are the characteristics of the image formed by a plane, sorry, concave mirror when the object is between P and F.